Greetings, chemistry student. So today we're going to look at a few things. First is accuracy and precision. Accuracy is getting the correct answer. Right? For instance, if you are using a infrared thermometer to take someone's temperature, if that thermometer shows what their body temperature actually is, it's considered to be accurate. Precision is getting the same measurement over and over again. So that would be if you use the same thermometer and you take numerous readings of the same person over and over again and you get the same temperature. That would be a very precise thermometer. Being precise does not necessarily mean that you're also accurate. For instance, the thermometer could be reading 2 degrees higher or lower than the actual temperature, but as long as it's giving you the same number, that's very precise, even if it's not accurate. Now, the equipment that we use in a science lab, particularly our digital scales, they tend to be very precise. They'll give you the same numbers over and over again, but unless you calibrate them regularly, they may not necessarily be accurate in giving you the actual values. So, this is kind of a representation if your goal is to hit the bullseye when playing darts. This first example is neither accurate nor precise. The second example is accurate, is precise, but not accurate. You got pretty close to the same answer over and over again. You're just supposed to hit down here. So, for instance, if you just aim a little bit lower and to the left, you'll hit the target. And this third example is both accurate and precise. A few things that you may have seen before, you may not have, but we'll go over them real quick. Physical properties are properties of a substance you can observe without changing the composition of that substance. So, for instance, if you're talking about how much something weighs, its volume, its length, its density, its color, its odor, its taste, its hardness, melting point, and boiling point, those are all physical properties. For instance, measuring out some water using a measuring cup in the kitchen does not change what water is made of. Boiling water does not change what it's made of. It's still two hydrogens and an oxygen chemically bound together. Chemical properties, on the other hand, are the ability of a substance to combine with or change into some other type of substance. For instance, whether something is flammable, if it rusts, if it decomposes, if it's caustic, all that type of stuff. So, for instance, if you're finding out that a piece of paper is flammable, well, you've set it on fire, it's no longer paper, it has reacted with oxygen and formed something new. Physical and chemical changes. A physical change does not change the composition of a substance. We haven't gotten into chemical formulas in this class, but you probably learned this in middle school. So if you don't change the chemical formula of what something is, that's a physical change. Cutting something up, breaking it, grinding it up, melting it, boiling it, all that stuff is a physical change. Chemical changes would change its chemical composition, and that would be doing a chemical reaction like setting something on fire, breaking it down, heating it up and causing a reaction to take place like cooking. For instance, once you fry an egg, you can't unfry the egg. You have chemically changed the composition of that egg by rearranging what's in it. So, next, we're going to talk about elements and atoms and all that good stuff. So, an element is a pure substance. It's made up of one type of thing. You can't break it down into anything simpler. There are, as you may or may not know, 118 elements that have been discovered so far. 88 of them occur naturally on Earth in any measurable amount. All right, so if we look at this periodic table right here from ptable.com, you can see that there are 118 different elements. And essentially, you can't take oxygen and break it down into something simpler than oxygen and it still have the properties of oxygen, or sulfur, or aluminum. For instance, you can take a piece of aluminum foil, You tear it in half, you still have aluminum. You keep breaking it down smaller and smaller and smaller, it's still aluminum because it only consists of one type of atom. By this point, you have a basic idea of what atoms are, I would hope. Right? And so there's 118 of them, 88 which occur naturally, and they're organized on the periodic table according to their properties. We'll go into much more detail about how this periodic table works and how it's organized. You've got one in your reference tables. It's on pages 4 and 5 of your reference tables. It looks like this one right here. Your reference tables stop with element number 112. There have been 6 more elements discovered and officially named since your reference tables were produced in 2012. So they're a little bit out of date, but we're not going to work with those elements that go down here, like tennessine and oganesson. We're not going to be working with those in this class. They're all highly radioactive and they're kind of like novelty elements. We're not going to be working with those. Now, each element has a 1 or 2 letter abbreviation for its name. That's its symbol. And what's important about this is when you write an element symbol, the first letter is capitalized, the second letter is lowercase. That's very important that you do that. For instance, if you write a capital N, capital O, as opposed to capital N, lowercase o, that means 2 completely different things. This would be nitrogen monoxide, which is a poisonous gas. This would be nobelium, which is a radioactive metal. So 2 very different things. The capitalization in writing these elements is very important. So don't get lazy with your capitalization. It's important that you capitalize the first letter, don't capitalize the second. So that's the elements and element symbols. Next, we've got compounds. A compound is a pure substance that consists of 2 or more elements that are chemically combined, and so to separate them would require doing a chemical reaction. Obviously, water, is a compound that consists of 2 hydrogen atoms and an oxygen atom. They're chemically combined. You can't easily separate them you can't separate them using physical processes. It requires some type of chemical reaction to separate the hydrogen from the oxygen. Most pure substances that you encounter are compounds. Now, if you take elements or compounds and you just combine them together without doing a reaction, you end up with what's called a mixture. A mixture is when you take 2 or more substances and you put them together, but they retain their chemical properties. So, for instance, if you take salt, sodium chloride, and you take water and you mix them together, you get salt water. It has some of the properties of water, some of the properties of salt. That's very different from a compound like water, where you have hydrogen, which is a highly flammable gas, and you have oxygen, which is a gas necessary for life. You combine them together and you get what's normally a liquid that's not flammable. Or salt itself, which consists of sodium, a very reactive silver colored metal, and chlorine, a greenish colored poisonous gas. You put them together, you get a white solid that's completely stable. It can sit in a salt shaker on your table. You don't have to worry about it blowing up or killing you or anything like that. So compounds, everything changes when you form a compound from the elements. Mixtures, they keep some of their same properties. And there's 2 types of mixtures. There's heterogeneous mixtures, like chocolate chip cookie dough, where you could pick out the chocolate chips from the cookie dough. And then there are homogeneous mixtures that have the same composition throughout. They're uniform. So, for instance, when you make salt water, you can't pick out the salt from the water very easily. There are ways to separate it, however. And when you come in person to school, you'll actually do a little lab one day where you will be separating mixtures into their individual constituent parts. Some ways you can do this: filtration is a way to separate mixtures. For instance, if you mix hot water with coffee grounds, you're making coffee, but you have coffee grounds mixed with it. Well, you have a piece of you have a coffee filter in there that separates the coffee grounds from the coffee solution that you're making and separates it out. In chemistry class, we use filtration to separate out larger particles. As long as it's not dissolved, filter paper will remove it. The second thing you can do is distillation, where you heat up a substance, and a substance in the mix, you heat up a mixture, and the substance with a lower boiling point will boil off, and the substance with the higher boiling point remains behind. That's used to make what's called distilled water, where you boil off the water and you leave behind any minerals. If you took water from the Atlantic Ocean and you distilled it, you'd be left with salt left behind in the flask where you were boiling it, and then you would be collecting the water without the salt. They also use this to make alcoholic beverages, distilled liquor, for instance, vodka, things like that, where you take a solution that contains alcohol and you heat it up to the boiling point of alcohol, which is lower than that of water, and the alcohol boils off, and you collect that and you leave behind the water. And just a quick note, doing that without a license from the federal government is a crime that they will prosecute you for. Do not try to make liquor at your house. Crystallization, if you've ever made rock candy, where you cause the solid to crystallize out as you evaporate out the liquid portion. And then there's chromatography, which is separating based on how quickly things move on different substrates. We'll do a chromatography lab later on once we learn the mechanism behind how it works. So I just want to leave you with this. This is a diagram of a distillation apparatus. For instance, if you put salt water in here and you start it boiling, the water vapor will boil. It goes into this condenser, which uses water to cool it off. And then the water will drip down here, and you can collect the water while the salt is left behind. Making distilled liquor is done the same way. This is what people who are called moonshiners are doing. And once again, doing so on your own, highly illegal. But these are valid laboratory techniques for separating mixtures. So I'm going to have a quick assignment for you to do. So with that said, hope you'll have a great day.